Now today we are doing the first shifting theorem of the Laplace transformation. So what is the first shifting theorem? If f(t) be a function of t having Laplace transformation that is L of ft equal to fs, then L of Laplace transformation of e to the power at ft, this is equal to f of s minus a. Okay, so if the function is multiplied by e to the power at, then whatever with the s, in place of s, we are putting s minus a. If it is multiplied by e to the power minus at, then it will be s plus a. Okay. Now example. So what is Laplace of 1? The Laplace of 1 equal to 1 by s. And we know that what is Laplace of, in the last class we have find Laplace of e to the power at. This is equal to 1 by s minus a. So now, how we are getting this value? If we apply the first shifting theorem, then we can write Laplace of e to the power at can be written in the form of Laplace of e to the power at into what? So here ft equal to 1, and what is the Laplace of 1? This is equal to 1 by s. Since 1 is multiplied by e to the power at, so in place of s, we are putting s minus a. So the value becomes 1 by s minus. Okay, clear? Now similarly, what is Laplace of sin t? Sin omega t. This is equal to omega divided by s square plus omega square. Therefore, Laplace of e to the power at sin omega t, this is equal to, in place of s, we will put s minus a. So omega divided by s minus a whole square plus omega square. So that means if anywhere in place of s it is s minus a, that means we have to use the shifting property. So it is multiplied by the function, main function is multiplied by e to the power at. Similarly, what is Laplace of cos omega t? Next, Laplace of cos omega t, this is equal to s by s square plus omega square. Therefore, Laplace of e to the power at cos omega t, this is equal to s minus a divided by s minus a whole square plus omega square, and so on. Okay, so this is the Laplace of this is the first shifting theorem. So if the function is multiplied by e to the power t, then in place of s, we are putting s minus a. Now, what is the next property? Now come to the next property. Change of scale property. So shifting property is the first one, and then the number 2 is change of scale. So what is change of scale? If L of ft is equal to fs, then how we can change the scale? Either it will be multiplied by some constant or it will be divided by some constant. So then Laplace of f of at, this is equal to 1 by a f of s by l. Okay, clear? I am not going to the proof. Just I am writing the formula. In the same way as before, if you find Laplace of f of at, very easily you can get 1 by a f of s by a. Okay. So now example, Laplace of sin t, this is equal to, here omega is 1, so 1 by s square plus 1 square. That is equal to 1 by s square plus 1. So therefore, Laplace of sin omega t, this is equal to, according to the change of scale property, this becomes 1 by omega f of s by a. That means where is s? We are dividing s by a, s by omega. So 1 divided by s by omega whole square plus 1. So after simplifying, we are getting 1 by omega 1 divided by s square plus omega square divided by omega square. Now this will be in the numerator, so this becomes 1 by omega square divided by s square plus omega square. So omega and this omega square cancel. So we are getting the value omega divided by s square plus omega square. So we know that Laplace of sin omega t is equal to omega by s square plus omega square. And here, by using the change of scale property, again we are getting Laplace of sin omega t equal to omega by s square plus omega square. Okay, so what is the formula? If L of ft is equal to fs, then Laplace of f of at, t is multiplied by a, then in the right hand side it will be divided by a, 1 by a into f of s by a. Okay. Now next property. That is the Laplace of the, if the function is the derivative. Okay, Laplace of derivative. So Laplace number 3 property. Laplace transformation of derivative. Okay. So how we will get this value, Laplace transformation of derivative? If Laplace of ft exists, that means L of ft equal to fs. Then I am not going to the details of the theorem. Just I am writing the formula. Laplace of ft equal to fs. Then Laplace of derivative of ft, this is equal to s into L of ft minus f of t. Okay, clear? So that means the Laplace of f dash t exists. Now similarly, Laplace of f double dash t. What will be the formula? This will be equal to, here observe this one, Laplace of f dash t. If we are doing 1 times derivative, then initially the power of s will be 1. And then Laplace of f t, it is fixed. And then what is the next term? This is f0. And all other term will be negative. So here, the f is differentiating 2 times. So the power of s will be 2. Laplace of ft. Okay? Minus the power of s will be decreased by 1. Now from the next term, the power of s will be decreased by 1. So this will be s into, what is the next term? f0. F of 0 minus, all other term will be minus. Again power of s will be decreased by 1. So s to the power 0. And now we are doing the differentiation of f and putting t equal to 0. So that means the f dash 0. Okay, clear? So what we are getting? S square L of ft minus s into f0 minus f dash 0. Clear? So if 2 times derivative, then the power of s will be 2, L of ft. L of ft is fixed. Then the sign of all other term will be negative. Power of s will be decreased by 1. Here it is 1, here it is 0. It is f0, it is fixed for all the derivative. And then from the next term onward, we are differentiating f 1 by 1. So f dash 0. Similarly, L of fn, it is not the power, it is a derivative. That's why I am giving here n within bracket. So nth time derivative. So what will be the power of s? Power of s will be n. L of ft, it is fixed. Now the power of s will be decreased by 1. Sign of all other term will be minus. So minus, the power of s will be decreased by 1, s minus n minus 1. f0, it is fixed, f0. Then again minus, because sign of all other term will be minus. Now power of s will be decreased by again 1. So s to the power n minus 2. Now we are doing the derivative of f and putting t equal to 0. So f dash 0 minus, again power of s will be decreased by 1, n minus 3, f double dash 0. Okay? Minus dot 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 minus. So what will be the last term? In the last term, the power of s will be 0. So there will be no s, because something to the power 0 is equal to 1. Now f. Now then this t will be 0. Now how many order derivative of f will be there? Now come to here. If it is 1 times derivative, then no derivative, 1 less than. If it is 2 times derivative, then in the last term there is 1 times derivative. That means 2 minus 1. If it is n, then in the last term the derivative will be n minus 1. N minus 1. 1 less than derivative. So f n minus 1, 0. Okay, clear? So if the function is derivative, then very easily we can get the Laplace transformation of that function. Okay. Now come to the next theorem. Laplace transformation of integration. Okay. So very easily, how we can remember Laplace, if the function is derivative, then remember this one, s into L of ft. That means L of ft is multiplied by s. So if the Laplace of integration of a function. Okay, Laplace of integration of a function. Okay, so if L of ft is equal to fs, then Laplace of integration of f tau d tau 0 to t. So f tau means ft. Since the upper limit is depending on t, that's why I am giving another variable tau, but the function is same f. So Laplace transformation of the integration of f tau d tau within the range 0 to t, the value will be here. If we are going to find the Laplace of the derivative, then the L of ft is multiplied by s. So if we are finding the Laplace transformation of the integration, then L of ft will be multiplied by divided by s. So 1 by s L of ft. Okay, clear? So if we are finding the Laplace transformation of the derivative, L of ft will be multiplied by s. If we are finding the Laplace transformation of the integration, then L of ft will be divided by s. In this way, remember, then it will be very easy to remember the formula. Okay, clear? Now come to the next property, that is, I think, number 4. Laplace of a function, don't write Laplace, if the function is multiplied by t. Okay, multiplication by t. So if the function is multiplied by t, then what will be the formula? Okay, again, if Laplace of ft is equal to fs, then Laplace of ft, if the function is multiplied by t, then what will be the formula? Minus derivative dds of fs. Okay, clear? Minus dds of fs. So if the function is multiplied by 2t t square ft, then how many minus? 2 minus will be there. Minus 1 to the power 2. Don't make it plus, because if you make it plus, then you cannot find the formula very easily. You will be in puzzle. So that's why don't make it plus. Initially write it minus 1 square, because 2 times t, so minus 1 square. How many order derivative? 2 times derivative. d2 ds2 fs. So we will differentiate fs 2 times. So similarly it will run. So Laplace of, if the function is multiplied by n number of t, ft, then what will be the formula? Since the power of t is n, so minus 1 to the power n. How many order derivative? Nth order derivative. dn dsn fs. Clear? So what is the formula? If L of ft equal to fs, then L of tft will be equal to minus TDS of fs, derivative. Now how many t will be there? That number of minus 1 will be there, and that number of derivative will be there for the function fs. Okay, clear? So let's come to the formula. come to some example, very easy example. What is Laplace of sine omega t? This is equal to omega divided by s square plus omega square. Therefore, Laplace of t sine omega t. This is equal to minus dds of fs. What is fs? Omega divided by s square plus omega square. So, if we do the differentiation, this is minus at first denominator whole square. That means if there is a whole square in the denominator, then remember that the original function is multiplied by t. Okay? Then s square plus omega square into derivative of omega, that is equal to 0, minus omega into derivative of s square plus omega square, that is 2s. Clear? So this is equal to 0 into something, 0 minus a plus 2 omega s. 2 omega s divided by s square plus omega square whole square. So what the formula becomes? Laplace of t sine omega t. This is equal to 2 omega s divided by s square plus omega square whole square. So if in the denominator this is s square plus omega square, then either this will be Laplace of t sine omega t or t cos omega t. If in the numerator this is 2 omega s, then it will be t sine omega t. Clear? Now come to the next function, that is Laplace of t cos omega t. Now we know that already we have proved, we know that Laplace of cos omega t, this is equal to s by s square plus omega square. Therefore, Laplace of t cos omega t, this is equal to minus dds of s by s square plus omega square. This is equal to minus again denominator whole square. That means if the denominator is whole square, then this will be obviously the function will be multiplied by c whole square. Then s square plus omega square into differentiation of s, that is 1, minus s into differentiation of the denominator, that is 2s. So what we are getting? We are getting s square minus 2s square. And then it is minus. So minus s square minus omega square plus 2s square divided by s square plus omega square whole square. This is equal to minus s square plus 2s square. So it becomes s square minus omega square divided by s square plus omega square whole square. Clear? So Laplace of t cos omega t equal to s square minus omega square by s square plus omega square whole square. So Laplace of t cos omega t, this is a very important formula. So whenever in the denominator there is s square plus omega square whole square, that means the function will be either t cos omega t or t sin omega t. If the numerator is 2 omega s, then it will be t cos sin omega t. If the numerator will be s square minus omega square, then it will be Laplace of t cos omega t. Okay, clear? So here we are getting the formula if the function is multiplied by t. Okay, clear? Now come to the next formula. If the function is divided by t, what will be the Laplace? The Laplace will be Next, number 5. If L of ft this is equal to fs, then L of ft divided by t. So if ft is multiplied by t, then it will be derivative. If ft is divided by t, then it will be the integration. This is equal to integration s to infinity fs ds. Clear? If ft is divided by t, then this will be the integration of the fs. And if ft is multiplied by t, then it will be the derivative. Okay? Now come to the question. From some of the solution of some of the question. Okay? So at first I am doing one example. If ft is divided by s. So question, find ft if L of ft is equal to 1 by s square into s square plus omega. Now here solution. Here what is fs is equal to 1 by s square into s square plus omega square. Now at first we have to find the function whose Laplace is 1 by s square plus omega square. Already we know that Laplace of sin omega t equal to omega by s square plus omega square. And Laplace of cos omega t is equal to s by s square plus omega square. But we cannot bring s. We can bring omega. Omega is a constant. So very easily we can write 1 by s square 1 by omega into omega by s square plus omega square. Okay? And now omega by s square plus omega square, this is the Laplace of sin omega t. So this is equal to, we are taking 1 by omega outside. Now how many 1 by s square? 2s square. 1 by s into 1 by s. And it is the Laplace of sin omega t. So according as per the formula, if the function Laplace of sin omega t, that means fs is divided by s, then what will be the formula? When the function Laplace of the function is multiplied by s, Laplace of the derivative, and this is the Laplace of the integration. Okay, whose integration? The function ft, the integration of ft. So this is equal to 1 by omega 1 by s. At first I will operate 1 by s into Laplace of sin omega t. Okay, slowly we will complete the solution. So it is 1 by s L of ft. This is equal to 1 by omega into 1 by s into Laplace of the integration 0 to t ft dt. So what is ft? Sin omega t dt. Okay, clear? Laplace of the integration of ft dt. So 1 by omega into 1 by s L of, now what is the integration of sin omega t? Minus cos omega t divided by omega. Putting the range 0 to t and then taking the Laplace. So what will be the value? The value will be the value will be 1 by omega into 1 by s Laplace of, if we are putting t, then this will be minus cos omega t by omega. Minus cos omega t divided by omega. Then putting lower range 0, so minus minus plus cos 0 equal to 1 by omega. So here we are getting 1 by omega, 1 by s, Laplace of 1 minus cos omega t divided by omega. Okay, clear? So now what is ft? Now this is ft. And this is Laplace of ft. That means fs. And again there is 1 by s. That means again we will do the integration. This is equal to whose integration? The integration of ft. Here what is ft? 1 minus cos omega t by omega. So 1 by omega Laplace of integration 0 to t ft dt 1 minus cos omega t divided by omega. Okay, clear? Dt. So what will be the integration? 1 by omega Laplace of 1 minus cos omega t. The integration of this is omega minus sine omega t divided by omega whole divided by omega. We can take this omega outside, that is omega square. Now we are putting the range, upper range, that is to lower range to upper range, that is 0 to t. If we are putting 1 by omega square, if we are putting t, the function will be remain same. Laplace of omega square minus sine omega t divided by omega. If we are putting 0 minus, we are getting omega minus t becomes 0, sine 0 equal to 0, it becomes 0. Okay. So this becomes 1 by omega square Laplace of omega square minus sine omega t minus omega square divided by omega. So we are getting 1 by omega cube Laplace of omega square cancel. Oh, we are doing the integration with respect to t. So integration of 1 becomes not omega, it becomes t. Okay. So if we are putting t, so it becomes omega t minus sine omega t by omega. And when we are putting lower range, that is 0. So t becomes 0 and sine 0 becomes 0. So this becomes 0 and this becomes 0. Okay. So here we are getting omega t minus sine omega t divided by omega. Okay, clear? So after simplification, we are getting 1 by omega cube Laplace of omega t minus sine omega t. That is Laplace of, we have to find ft, so we have to take 1 by omega cube within the Laplace. So omega t minus sine omega t divided by omega cube. So what is the ft of the corresponding fs? Therefore, so in the left hand side, what is fs? 1 by s square plus omega square. Okay. What is ft? So now this becomes ft. Therefore, ft is equal to omega t minus sine omega t divided by omega t. Okay, clear? So it is very easy. Just we have to remember the formula. If L of ft is multiplied by s, then this is the Laplace of derivative. If L of ft is divided by s, then this is the Laplace of the integration. Laplace of means the function should be the function of t. And what is the range of the integration? 0 to t. Because ultimately you want the function of t. So Laplace of the integration. And what is the range? 0 to t ft dt. And Laplace, if L of ft is multiplied by s, then it is the Laplace of the derivative. If the power of s is 1, Laplace of f dash t. If the power of s is 2, then Laplace of f double dash t, and so on. But in the Laplace of the derivative, there exists more than one term. But in the Laplace of the integration, there exists only one term. But to remember the formula, we have to remember in this way. That when we are going to find the Laplace of the derivative, it will be multiplied by s. L of ft is multiplied by s, and when we are going to find the Laplace of the integration, then this will be fs will be divided by s. If you so to get more update of this series, don't forget to like, share, comment, and follow this channel. Thank you for today.